The second property of logs has to do with division and subtraction. And if you're observant about it, you'll notice that there is a connection between the properties of logs and the properties of exponents. I'll point that out to you, and there's a reason for that. So the second property is this. If you have an iPad that'll write properly. There we go. Log base b of m divided by n. So in this case, the argument of your logarithm is a quotient. That is equal to log base b of the numerator minus log base b of the denominator. And so if you have an argument that is a quotient, you can write that as individual logarithms that are being subtracted, and you would have the numerator in the first and subtract the denominator from it. Now, if that looks a little bit familiar, it might be because you are thinking of this. If you have x to the m power divided by x to the n power, we know that we can subtract those exponents. And so we've already seen this connection between division and subtraction when we were working with exponents. So it shouldn't come as any real surprise that you see that same connection when you're working with logarithms. And in fact, the reason for that is because a logarithm and exponent are just inverses of each other. You can write one as another. And so you saw this on your reference sheet, actually, for your EOC. Whoops. If you have log base b of n equals m, that can be written as b to the mth power equals n. And so we know that we can take anything that's an exponent and we can write it as a logarithm. So it makes sense that the properties that govern exponents would be similar to the properties that govern logarithms. And in a higher level math class, like maybe a pre-calculus class, or sometimes in my college algebra classes, I'll go through and I'll prove the properties of logarithms. And the way that I would do that is I would take the logarithms, change them over to exponents using this property, apply the property of exponents, and then change them back into logs. In a nutshell, that's how that works. So as with the last lesson, I'm going to show you 3 examples of what it looks like to expand, 3 examples of what it looks like to collapse, and then give you, in this case, just 6 additional problems to practice. This one's a little bit harder to come up with more examples because when you end up subtracting more than 2 things, you end up with some issues when you try to like collapse them and stuff, which we will address when we get to like combining the properties, but we're not quite there yet. So here are our expand examples. Not a bad idea to write these down so you can look at them later. We have log base 3 of a over b. And so you would notice that you're taking the log of a quotient. And so that can be written as 2 logarithms, the logarithm of the numerator minus the logarithm of the denominator. And you do need to keep the base there. I'm aware that writing the base is kind of annoying to keep doing. And in multi-step problems, when we get to the very last lesson, we start combining the properties and you have multiple steps in the expanding and the collapsing. I'm actually okay if you drop the base while you're doing the scratch work, as long as you remember to put the base back on the logarithm when you're done. Second one is the log of 4 over x. And remember, and I'll keep emphasizing this, when you don't see a base, the base is 10. That is a a common log. Make sure I get my vocab right. And so this would be the log of the numerator minus the log of the denominator. So throw like a constant in there. So we're not dealing exclusively with variables. And the last one is log base 7 of 1/2. And so that could be written as log base 7 of 1 minus log base 7 of 2. Okay, and we can also go in the other direction. So that would be our collapse direction. If you are given a logarithmic expression and it's already written out with the subtraction, you can collapse it and rewrite it as a single logarithm of a quotient, and you just take the first argument and divide that by the second argument. So here are our there we go, collapse examples. And the first one is log of 6 minus log of 2. Now, if you don't slow yourself down and pay attention to the properties, you might look at this and say, oh, that's log of 4, but it's not. That's not multiplication. It's not log times 6 and log times 2 that you could factor out the logarithm and just do 6 minus 2 is 4. It's governed by other properties, which of course, again, are related to the fact that these are the inverse of an exponent. So if you wanted to collapse that, that would be log of the first argument, which is 6, divided by the log of the divided by the second argument, which is 2. And of course, 6 over 2 is 3. And you could check this on your calculator. You can do log 6 minus log 2 and get a decimal for that, and then check that, do log 3, and see if you get the same decimal for it, and you would. Second example is the natural log. Remember that it's just log base e. Natural log of x minus the natural log of y. So that would be the natural log of first argument divided by the second argument. So x over y. And the last example is the natural log of a minus the natural log of 3. And that, of course, would be the natural log of a, the first argument, divided by the 3. And there you go. So on your piece of paper that you have, so you already have your first assignment, which was up there, okay? And now we're going to add to that. So we're going to do problems 11 through 16. On the left-hand side, as before, I'm going to put the expand problems, and on the right-hand side, I am going to put the collapse problems. And here they are. As with last time, I will read them out loud just in case there's anything that you can't read. Number 11, log base 5 of 3 over 4. 12 is log of n over 6. 13 is the natural log of x over y. 14 is the natural log of 8 minus the natural log of 4. 15 is log base 3 of a minus log base 3 of b. And 16 is log base 6 of 7 minus log base 6 of y. And do this on the same piece of paper that you started with the first properties of logs assignment, and then you have completed the second lesson.